This lesson is about more practice with radicals. We're going to talk about the issue about when it's stated that answers must be simplified. It all depends on the method of which we're going to simplify and which method you're asked to simplify as. If you're asked to simplify using exponents, you would change this from radical form into exponential form, which means I would have 12 to the 10 over 4. Well, 10 over 4, 10 fourths, reduces, and you end up with 12 to the 5 halves. And that would be reducing or simplifying this problem using exponents. But it's not a simplified problem if I was asked to look at it as a radical problem. So it's not simplified as a radical. So let's look at how we're going to do that. To simplify this as a radical problem, we would factor this. Instead of 12 to the 5th, I'd write it as the square root of 12 to the 4th times the square root of 12. Well, the square root of 12 to the 4th is 12 squared, and 12 happens to be 2 root 3. 12 squared is 144 times 2 root 3, and I get 288, the square root of 3. And so this is the simplified radical form. It all depends on if you're asked to simplify in exponential form, or if you're asked to simplify and have your final answer in radical form. Now you'll notice to actually simplify this into radical form, I had to go through the exponential form. Because looking at it in the very beginning, the 10th root of 12 to the 4th, I could not simply have done that straight to 288 square root of 3 without first converting it to exponential form, reducing, and then rewriting it in radical form. Let's look at another example here. I have the 6th root of 18 to the 4th. And again, as it's written right now, well, how many 18s are inside there? There's only 4 of them, and this is the 6th index, and so there aren't enough to take out. But if we prime factor 18, we get 2 times 3 squared. So 18 to the 4th is 2 times 3 squared, all raised to the 4th. And therefore 18 to the 4th is the same thing as 2 to the 4th, 3 to the 8th. So in exponential form, when I have the 6th root of 18 to the 4th, I'm going to have 2 to the 4th times 3 to the 8th, all raised to the 1/6 power. Now I'm going to distribute that 1/6, and I get 2 to the 4/6 times 3 to the 8/6. Reducing each of those exponents, I get 2 to the 2/3 times 3 to the 4/3. And that would be considered simplified in exponential form. But if we were then asked to rewrite that into radical form, notice that both of those bases have a denominator in their exponent of 3, so that means the index would be 3. And it would be 2 squared and 3 to the 4th. But 3 to the 4th, I have enough that I can take that out. That's 3 to the 3rd times 3 to the 1st. So one of the 3's can come out, and one of the 3's is left behind. So the cube root of 2 squared, 3 to the 4th, reduces to 3 times the cube root of 2 squared, 3 to the 1st. And 2 squared is 4, 3 times 3 is 12. So my final answer in radical form, simplified radical form, is 3 cube root of 12. Let's look at another one. And we're going to simplify. That's all it says, is to simplify, nothing else. It doesn't say what format. It's given in radical form, so that would indicate that my simplification should be in radical form, the final answer. So first of all, I'm going to prime factor the radicand. I've got 250. That's negative 250, though. So we remember that, oh, that's a negative 1 times 5 cubed times 2 to the 1st. That negative 1, now negative 1 could be written as negative 1 cubed, or it could be written as negative 1 to the 5th, because if you just keep multiplying your negative 1s, negative 1 times negative 1 times negative 1 times negative 1 times negative 1, you're still going to get negative 1. In fact, any odd number of negative 1s, 7, 9, any odd number that where the power is an odd number, I'm still going to get negative 1. So I'm going to write that negative 1 as negative 1 cubed, since I'm looking for cube roots. So the radical form of this, I'm not going to look at the exponential form, I'm just going to look at the radical form and say I want the cube root of negative 250. If I plug in those prime factorizations, I can see, I can pull out the negative 1 and I can pull out a 5. And what's left behind is a 2 still under the cube root's radical. But don't forget that there was a negative all the way out in front. So this is actually asking not just for the cube root of negative 250, but the negative of the cube root of negative 250. So I'm going to negate that answer that I had up above where I did it in radical form. And a negative times a negative is a positive. So I'm going to get positive 5 cube root of 2. And this wouldn't simplify any further. I did not have to go into exponential form to do this. I really utilize, and what I utilize most of the time is prime factorization. So there's my final answer.